I am Mayank. In today's session, we'll talk about Kepler. It's a power users monitoring tool for the Kubernetes. So we can monitor the power uses for our process, our container, and pod level power uses and the for using the Kubernetes. And so let's get started. So before I move further, so let me introduce myself. Hi, I'm Mayank, and I'm currently working at Okta as a senior SRE in the workflows team. So workflows is a new product from Okta, which helps you to automate all the identity processes without writing a single line of code. So it's been 8 months for me working in Okta, and before Okta, I worked at Zoom meetings, you might have known, as a DevOps engineer, and before that, I worked at Red Hat as a software engineer. And in Red Hat, I would like to mention that I found a passion for open source and automation. So I believe that's why I'm standing here today. All right. So agenda for today's session will talk about what is sustainability and what are the current challenges we have with the sustainability and what are the solutions coming from the CNCF, Cloud Native Computing Foundation. And then we'll talk about Kepler. So this is the tool we're going to use today. This will help us provide the power uses for our process, container, and pods. And then we'll look at the Kepler architecture. And finally, I'll show a quick demo. All right. So let's talk about sustainability. Where we go today, people are talking about AI. But for a change, we'll talk about sustainability because we'll talk about the climate change. This talk is very enlightening for me, especially when I was preparing for it. Because when I saw Kepler, when I worked on it, Kepler, I found it something which is really useful for the C-level people in the company. And CNCF is working towards sustainability a lot. So they have a lot of projects coming up and they're working towards sustainability data centers and computing and sustainability cooling centers. So basically today's presentation will be like a one-on-one on Kepler. So before I start, I have a quick question to everyone. So how many of you use Kubernetes in day-to-day work? All right. So in Kubernetes, you must be deploying your VMs, your pods, your sandboxes and VMs. So may I know, have you wondered what is the carbon footprint of your workload? So let's say if you're running a pod, you are deploying a pod, you're deploying any application. Have you wondered what is the carbon footprint for your application? How much power it's using and how much carbon emission is there? Anyone? Oh, nice. Okay, so today's session will help you understand this. And most of the C-level people in the companies like Google, Apple, so they have commitment for zero carbon emissions by some years. So I can give you examples like Microsoft is committed to become carbon negative by 2030. And Google is also carbon neutral since 2007. And it's aiming to operate on 24/7 carbon-free energy by 2030. And Amazon also took a climate pledge, so committed to net zero carbon emission by 2040. So what is sustainability? As you might know, there are multiple definitions for sustainability. So sustainability is something, it's creating a product and technology which does not deplete our natural resources. Because I can give you a real quick example of data centers. So data centers we have around the world, they are consuming around 2 to 3% of the global energy or global electricity, which is huge. So I have a number written over here. So in 2024, it was amounted around 1.5% of the global electricity. And in 2025 itself, it cited around that it will going to use 2% of the global consumption. So we are talking about this scale, 2% of the global electricity is being consumed by data center itself. So you can think of how huge it is. And why the energy use is significant here? Because massive computing power is needed. For cloud services, we have cloud services like AWS, Azure. We have AI ML training. So this requires big data centers and it uses a lot of, and we have video streaming data centers like Netflix, YouTube, gaming, IoT, and big data. So these also consume a lot of power and energy. And to keep the data servers cooled down, we have cooling systems which consume a large chunk of total energy to keep the servers away from overheating. And here's the breakdown of energy consumption we have. So we have servers and storage. It takes around 40 to 45 to 50% of the total energy we have in data center, and the cooling system itself takes 30 to 40%, and network takes around 10 to 15%, and lightning and other thing takes around 5%. Carbon energy accounting is complex because we have diverse hardwares, virtualization, missing data, and AI/ML. So it makes really hard for us and for everyone to measurement the carbon emissions from the data centers. And also there is a user lack awareness. Like I asked 2 minutes ago, how many of us tracks the carbon emission from our workload? So mostly no one takes care of it except one. So that is another problem. And there is a sector-specific constant also. For example, telco prioritize reliability, and the finance sector prioritize speed and compliance. And both are very limiting the energy saving options for us. So that is the challenges we have in the sustainability. So what are the solutions we have? So solutions we have is CNCF. They have a special team called Technical Advisory Group on the environmental sustainability. And the group is responsible to support the papers, the innovations, and the tools to reduce the carbon footprint from the data center to your applications like your pod, containers, etc. So sustainable cloud computing has a landscape. So this is how they are trying to reduce the carbon footprint of the data centers or your applications. So these are the efforts going on for the sustainability. So first pillar we have is infrastructure tooling. So they want to work on the scheduling, scaling, and the resource tuning. Then we have the observability tooling, and then we have the data centers like smart data centers, cooling, and BMC. Then we have the different methodologies is being given by CNCF. But since we'll talk about Kepler today, Kepler comes under observability tooling, so we'll focus more on that. So observability, as you might know, that it refers to the tools and methods that gonna help us to measure and monitor the resource uses and energy footprint for the cloud native workloads. And under the observability tooling, there are like multiple tools we have. One is gprofiler. So gprofiler, I guess most of you already knows. So gprofiler tells you which part of your codes will gonna take most of the time, where most of the which function of your code will take most of the time when you run any program. And then we have a Power API, a Python framework, and Kepler, and Green Metric tool, cloud carbon footprint, influx data, carbon QL, Power TDP. But since the main topic for today is Kepler, so we're gonna focus on Kepler today. So Kepler is a Kubernetes efficient power level exporter. So it's a metric exporter that gets fed to Prometheus to track the power consumption of our pods, container, and processes. So the Kepler project was started by Red Hat and IBM together in February 2022. And later it was donated to CNCF as a sandbox project in 2023. So let me explain what Kepler does. So Kepler is what it does. It will take your process, containers, and your Kubernetes pods, and it will give you the metrics about how much power consumption is done by all your process, container, and Kubernetes pods. And it does the real-time metrics collection from your servers, from your pods, and it push it to the Prometheus. And through Prometheus, you can load the dashboards to the Grafana, and you can visualize all the power consumptions. And basically, there are the three functions that generally offered by Kepler. The one is real-time metrics collection. The second one is Kepler collects all the resources used in the machine using the eBPF program. So eBPF generally a program that injected into a kernel pathway. And through that, you can check the process, how much resource consumption has been done by process. And it also uses other APIs like REPL from Intel and NVIDIA Management Library and other tools that gets your metrics about your power consumption. And through that, it can give you the exact numbers about how much consumption is being done at the pod level, container level, or the process level. And finally, Kepler reports the per process, per pod energy consumption in the Grafana or in Prometheus. All right, so I'll give you a brief about how Kepler works. So Kepler, let's say if you are deploying Kepler on the bare metal. So in the bare metals, we have APIs or tools available like REPL, sensors, IPMI, GPU. These helps us to get the metrics of power consumption, and these power consumption metrics and then feed it to the ratio power model. What is the ratio power model? I'll talk in some time. And then it takes the ratio of your process utilization versus your system utilization, and it multiplies by the dynamic power uses, and through that it gets the data about power consumption for your process, your container, and your pod, and then it feeds to the Prometheus, and from that there we can visualize. In the first diagram you can see we are deploying Kepler on the bare metal. Now in this second diagram, if you see, we have bare metal, then we have virtual machines, and then we have trained power models. So what is that? When we deploy Kepler on the bare metal, so on the bare metals only we have technologies available like RAPL from Intel and GPU by NVML, NVIDIA Management Library. But on the VMs, it's not available. So you might be thinking like how Kepler can give you power consumption metrics if it's deployed on VM. So for that, what Kepler does is it has their own trained power model. So basically, whenever you run Kepler, it generates machine learning, regression-based machine learning models, and it pushes the data to the GitHub to keeps their model up to date. So it works in offline and online mode, which we're gonna discuss more about it. And so in case of VM, we have trained power models, and then it takes the process utilization versus the system utilization, and it multiplies with the dynamic power. So like two power, absolute power is like dynamic power plus the ideal power. It takes dynamic power, and with that it calculates the consumption of power for process and container. And the third one is pass-through estimated VM process metrics. So in this what we do is we install Kepler on the bare metal, and we have VM also on the bare metal. So through the C group files and hypervisor hypercalls, we can get the power consumption metrics. But this is still in process. This is not available yet. So we are not going to discuss much about the third one, pass-through estimated VM power metrics. And then we have the Kepler power model server training. Like I said, in case of VMs, it does not have any way to get the power metrics from the VM. So that's why we have a power model server training. So in that, what Kepler does is Kepler have the label metrics. It exported on port number 9102, and it gets to the Prometheus, and Prometheus queries it, and then we have the model server. So in the model server, firstly we get the raw Prometheus data, and then we get the data extraction. So data extraction is like removing the outfillers, and then we convert the matrix to the gauge matrix, and then we have the data isolation. So like I mentioned, we have it extracts the ideal versus the dynamic power, and from the absolute power, and then it normalizes the data, and finally it trains the data. And like I said, it works in two models. One is offline and one is online. So in case of online, it pushes the data back to the GitHub so that we can have the GitHub repo up to date. But in offline, it will train your model, and for let's say if you have new VMs, so it can accurately gives the power consumption for that. And that's how we get the power model. So now let's walk through the demo. Okay, so I'm running a cluster in GKE. So we have a Kubernetes GKE cluster. So in that, I have installed the Kepler using the Helm chart, and it's exporting the metrics on port number 9102. And you can see we have all the matrices available. It tells you about the matrices of your process, of your container, and of the pod also. And then we are using Prometheus. And in the Prometheus, we can scrap the data by creating a service discovery. And then from the Prometheus, you can use Kepler. So in the you can use Grafana. In the Grafana, you can create dashboards. And through the dashboard, you can see how much power consumption has been happening using container, and total power consumption per pod, and power consumption per namespace. So I can show you. So this is, for example, at 353, it was using 497 joules, and now it's going down to 497 joules. So like that, you can track the power consumption container level, and then we have the total power consumption also. So this also you can track using the visualization dashboard, and we have many more dashboard you can create as per your requirement. And this is the good topic which you can take back to your C-level people. So like, for example, under the infrastructure people, those heads the infrastructure pillar, so that you can tell them how we can monitor the carbon emission or power uses for our resources and how we can track it down. And basically you can get a report to the developers and operators, so they can track it and they can reprofile it, or they can make it much better, and through this we can maybe reduce the power consumption. And apart from this, CNCF is also doing a lot of efforts. For example, they are bringing up a new product, I forgot the name, so that will also help you to reduce the power consumption. It will help you with the green computing. And yep, that was a little short demo and presentation about how Kepler is working. Though Kepler is still there are a lot more changes coming in future for Kepler. Now it's still growing up. Yeah, if that's all from me. If you have any questions, please feel free to ask. Thank you. No questions? Thank you. Yeah.
Right. So you talked about sustainability. Is it possible to then correlate the power consumption with the actual carbon emissions coming from various?
So in the data center, how we get the electricity, because of fossil fuels. So fossil fuels generates the electricity, and based on the uses of the electricity, we can assume that, okay, let's say if we used around 1 gigawatt hours of electricity, so that might have had emission of around 200 kilograms or 200 tons of carbon emissions. So with the power consumption at the port level, the process level, we can same way we can calculate, okay, so let's say if it is 165 joules, so based on the 150, 65 joules of the electricity consumption, how much carbon emission has happened. So that's how you can track it down.
Okay, but there's no functionality of doing that.
So far, there is like no direct function or methodology available. So to calculate, okay, so let's say if you have consumed this much of electricity, you will have this much of carbon emissions. It's not available for now, but maybe in future Kepler might have will introduce it.
Okay, thank you.
You mean the data center are like physical providers? Yeah. So like I said, the cloud providers have commitment to get carbon free by some years. So there are like few methodologies has been introduced by CNCF. So for example, smart data centers, and the smart data center will have less carbon emission, and they will work on a different energy, not that energy which is not different kind of electricity which is not being generated from fossil fuels. So that will have less carbon emissions. But this is like still work in progress. Like I said, Kepler is just introduced like few years ago, and data center will trying to use technologies and methodologies introduced by CNCF, and by around 7 to 8 years we'll see some impact of their like less carbon emission at the data center level also, and at the application level also. But like I said, if you're using it and like this for yourself, you are reducing the power consumption, if I understood correctly, right? Not looking at the data center, but what we are consuming is very less amount. What data center are consuming the electricity, the carbon oxide footprint, it is very high. So at the data center level only we need to think of it. And for example, the big cloud providers like Azure, AWS and Google, so they need to think of different methodologies with introduced by CNCF, and they are, I guess, already working parallelly with the CNCF to reduce the carbon emissions. And they'll probably use green energy, we call it. So they're probably in some years they'll fully shift to the green energy from the energy we are using today. So that way they can significantly reduce it. Sorry? Green energy is like the way of generating the electricity in a better way. So not using the fossil fuels, but some other modes of to generate the electricity. Yeah.
Cool. So just mentioning the hyperscalers there, obviously, if you're in a US data center, say in Arizona, versus a data center in Sweden or something like that, and they've got different energy generation methods, and they've potentially got different hardware running in there as well, some more energy efficient hardware to calculate whatever you're running against. does Kepler account for that, or does it just take an average over the hardware that's running?
So it's take average for now. It's not very mature. So at the process level, also at the container level, at the pod level, only at the 3 levels it's working for now. But at the bare metal level, deep down, it's not very compatible as of now. And you can deploy it as on the Linux machine with the containers, and you can deploy. Of course, you can deploy on the with the Kubernetes. But apart from that, so there is no way you can on the big scale. You can Any more questions? All right. Thank you, everyone.